In this presentation, we will discuss training and testing data, the two essential components for building and evaluating machine learning models. We'll explore what each type of data is, how it's used, and why it's important to use separate sets of data for training and testing. By the end of this presentation, you'll understand how training and testing data work together to power machine learning models. Training data is the fuel that powers machine learning models. It's the data that the model is trained on, and it's what allows the model to learn and identify patterns. Training data is typically labeled, meaning that the desired output for each data point is known. For example, if you're training a model to classify images of cats and dogs, the training data would consist of images labeled as either cat or dog. The more training data you have, the better your model will be able to learn and generalize to new, unseen data. Testing data is used to assess how well your machine learning model performs on unseen data. It's important to use testing data that the model hasn't seen before during training. This helps to ensure that the model is generalizable and can make accurate predictions on new data. Testing data can also help to identify overfitting, which is when a model performs well on the training data but poorly on unseen data. The size of the testing data should be representative of real-world use cases. It's essential to use separate training and testing data to avoid overfitting. Overfitting occurs when a machine learning model memorizes the training data too well and cannot generalize to new data. This can happen if the training data is too small or not representative of the real world. By using separate training and testing sets, we can help to ensure that the model is learning the underlying patterns in the data, not just memorizing the training examples. Training and testing data work together to build and evaluate machine learning models. The training data is fed into the model, and the model learns to identify patterns and relationships in the data. Once the model is trained, the testing data is used to evaluate its performance. The results of the testing data are used to fine-tune the model or identify areas for improvement. This iterative process of training, testing, and refining is essential for building effective machine learning models. In conclusion, training and testing data are the cornerstones of building and evaluating machine learning models. Training data provides the foundation for the model to learn and identify patterns in the data. Testing data helps to ensure that the model generalizes well and can make accurate predictions on new, unseen data. By using separate training and testing data sets, we can avoid overfitting and build robust machine learning models. I hope this presentation has been helpful. If you have any questions, please feel free to contact me.